academic, Tuesday, March 14th. Okay? All right, so we left off with, we were using the law of sines, right? Little review, right? Simple enough, right? Why was it simple enough for these cases? So in all of these cases, they gave us two angles and a side, right? So here they gave us these two angles and the side in between them, right? We had angle, side, angle. Okay, so angle, side, angle. We also have side, angle, side. Angle, angle, side. Side, side, side. Right? These are the four ways in geometry that we could prove two triangles congruent. Right? They have to be the same triangle because if you know an angle, a side, and an angle with like a side that's sandwiched in between them of a triangle, you automatically know what the rest of the triangle's like sides and angles are. Okay? The same goes for these other three ways of proving two triangles congruent, right? You couldn't do what? You couldn't use what, though, to prove two triangles congruent? ASS. Could not do it. Weren't allowed to do that, right? Right? Because if you know the angle, if you know a triangle's angle and then two of its sides, right? There are two different possibilities for constructing the rest of the triangle, okay? We run into the same problem when we're using the law of sines, okay? This is what's called the ambiguous case. When they give you angle, side, side, you get what's called the ambiguous case. All right? It's the reason I always use the law of cosines in pre-cal. But if you like the law of sines, you got to watch out for the ambiguous case. Okay? Got to watch out for the ambiguous case.
Does that mean you just can't solve it at all?
You can. You just have to keep in mind that there might be like two different answers for everything. If that makes any sense. All right, so let's start with this first one, right? They gave us an angle and two sides, right? Let's draw a triangle in. Oh, gosh. So we have three angles, big A, big B, big C, and then little a, right? Little review, right? Notation. Angles get capital letters, sides get small letters, right? And then we put the same letter across from each other, okay? So B is going to be 82 degrees. Okay, little b is 17. Little c is 15. So when they give you ASS, you run into the ambiguous case. Okay, so let's fill in, right? Law of sines was sine big A over sine little a equals sine big B over sine little b, which equals sine big C over little c, okay? So basically what's going to happen here, because they gave us ASS, there's going to be two different triangles that solve this equation, that we can plug into the equation, okay? But there could be. I can say there could be. There could be zero as well. It's like the quadratic equation. There could be 0, 1, or 2 solutions. All right, so you got to be careful. Okay? So let's do this. Let's plug stuff in, okay? So we know what? We know big B and little b, so let's plug those in. 82 degrees and 17. All right, so let's solve for sine big C over sine little c, okay? Yeah, you do have 15, yeah. I was like, how do I do this? And I was like, wait, I have 15. Okay, so we're going to do what here to solve for big C?
Is it sine 17 and sine 15 underneath, or is it just 17, just 15?
Just 17, just 15. Good question. So we're going to cross multiply. So 15 sine 82 degrees. That's going to equal 17 sine C. Okay. So divide by 17. What's going to happen here, right? Since we're solving for angles this time, up here we didn't have to do inverse trig the other day in class. Okay, so we have sine C equals 15 sine 82 degrees all over 17. How do we get big C by itself? How do we break it out of a sine? Inverse sine, right? That's going to cancel my sine, so I'll have C equals inverse sine of 15 sine 82 degrees all over 17. Okay? You guys think you might have trouble doing that in your calculator? Let me write it down on the board real quick. All right, so let's do that in our calculator, okay? All right, so let's make sure our calculator's on degree mode. I'm on degree mode, so that's good. All right, 15 sine 82. 15 sine 82. Put that in there, hit enter. Okay, and then do divided by 17. Okay. I hit enter twice in that process because I want my calculator to do the correct order of operations, okay? Sometimes fractions and dividing can get kind of confusing in your calculator. And now I'll do the inverse. Yeah.
Okay.
Now I'll do inverse sine of that. So do second. Oh, that's still so cool. Second inverse sine of the answer key. You guys know where the answer key is and what it means? So the line, the answer, like the number that's on the last line here, that's going to be stored as answer, the ands variable. So it's second and then the negative sign. Okay. So ands is equal to this last line here. That's what that means, okay? I find the inverse sine of that. That angle is 60.9 degrees.
Are we okay to plug that whole thing in?
What?
Plug the whole, all of that, what you just did, can we just plug it all in?
At once.
Yeah.
If you
It got the same.
If you get the same thing, I'm just a little worried that your calculator might get confused. Like if you did like that.
I put it into fraction form, but yeah.
Yeah.
Like I made it a fraction.
Yeah, you can do that. I just do it this way. I show this way because it's safe. Yeah, but if you like, are you talking about using the alpha button?
Yeah.
Yeah, you can do that. Okay, so 60.9 degrees is what we get for angle C. So let's fill that in, 60.9 degrees. Okay. How do we get that third angle then? do I get that third angle?
Subtract.
Yep, subtract
those
from
two
180.
together.
Good. It's 37.1 degrees. There we go. Okay. All right, so then we can use that. So there was only one triangle possible here. Okay? Because now we have side, angle, side. So now there's only one possibility for that last side. I'm trying to think of the best way to explain this. Okay? So if they had given us different angles here though, if instead they had given us imagine they hadn't given us that 37 angle. Oh, come on. Sorry, this looks messed up. Imagine they had given us the 15, the 17. I'm trying to think of the best way to say this. If they had just given us, if they had just given us B2 plus 37, okay. Yeah, it'll probably be better. Let's keep moving, okay? How would I find that little a right there? Then, that last one. The last little a. I would do what? You guys know how to do this. How do I do that? So I have that big A, right? Let's plug the big A in. We can cross multiply on this side, yeah. So we have 17 sine 37.1 degrees equals A sine 82 degrees. Okay. Divide both sides by sine of 82 degrees. Okay. So that's our answer for A right here. That canceled out. So little a is going to be 17 sine 37.1 divided by sine 82. So 10.4. So little a equals 10.4. Big C equals 60.9 degrees. Big A equals 37.1 degrees. Okay. So this was an example where only one triangle was possible.
Do you want us to write out the answers like that, or can we just label the triangle completely?
If you label the triangle, I'll take that. Yeah. Yeah. So that was an example where only one triangle was possible. Can I move on to the next one? You guys follow that? Questions? All right, let's move on to the next one. All right, B. So let's draw a little triangle. Big A, big B, big C. Little b is 28, little a is 24. Big A is 73. Okay, so this is an ambiguous case because they gave us angle, side, side. They give you angle, side, side, there might be two triangles with those same measurements. There might be none. There might be no possible triangles that have those measurements, okay? All right, so let's just check this out, okay? So plugging everything in, so we start with sine A over A equals sine B over B equals sine big C over little c, okay? So let's plug in big A. Plug in little b. Let's plug in little a. Alright, we don't know big C or little c. Alright, and then how do I solve for big B right here? What do I do? Cross multiply, okay? Divide both sides by 24. And then I do what to both sides? After I divide by 24? Inverse sine, right? So B is going to be inverse sine of all this. Okay. And I'll do it the way Ben asked me. So inverse sine, do inverse sine. It'll be easier for you to see it if I do.
I don't think it works on this one.
Yeah, why not? What happens? Boom. What happened? Why doesn't it like it? Alright, so this number here, this is about equal to 1.11. If you crunch it in your calculator, it's about equal to 1.11. Okay? So if you inverse sine of 1.11, we're telling our calculator to find us the angle whose sine is 1.11. Right? Look at this. Look at the sine function. I'm going to switch my calculator ratings just for a quick second. Okay? Look at this. Check me out, check me out. Look at that. That sine curve, it never goes above 1 or below -1. Okay? There is no angle whose sine is greater than 1. Okay? So this triangle, what we're trying to do, we're trying to draw an impossible triangle. We're trying to draw a made-up triangle. So there's no triangles possible. Okay?
So whenever it gives you an error, there's just nothing possible.
No triangles possible, yeah. So we basically, what we did was we took the law of sines, we plugged in these three numbers here, and tried solving for b. That's just impossible to get. That's a contradiction. Not even God can draw a triangle like that. I already made that reference in here, right? He can do anything that's metaphysically possible.
Yeah,
Because he can't, right? Saying God can't make a triangle with these three measurements is the saying is God can't what? God can't.
yes.
It's meaningless. Okay? The modern philosophers believe that God could even do metaphysical contradictions, but you run into some problems with that. The medieval philosophers understood that God cannot do metaphysical. He cannot contradict himself. What's up? Yeah.
You don't feel good about modern philosophy?
I don't know enough. I just dabble. There's pros and cons. All right. But yeah, God cannot contradict himself. There's a school of thought called voluntarism where God can will whatever he wants. So he can even will that you disobey him. It's I don't know about that.
That's freaky.
I don't know about that. Yeah, so a lot of people don't like that. Anyway, yeah. You guys want to do this next one real quick? Let's do this next one. So that was an example where there are none. So you're going to get an error. You're going to get some impossible number, right? You cannot plug 1.1 into the inverse sine function. You can't do it. It's meaningless. It's a meaningless statement. That's like telling me the measure of this circle's right angles, right? It's not just wrong. It's like doesn't even have meaning. You can't even like use the word circle and right angle in the same sentence, or else you don't have a circle anymore, right? What's a good example? You can't have a circle with right angles. So if I use that, if I use like find the right angle of a circle, like that's a meaningless phrase. I think it's meaningless. All right, so let's fill in big A, big B, big C. 32 degrees. So when your friend in college is like, God cannot create a rock so heavy that he himself cannot lift it, just say like what you're saying. So you're telling me that God can't. Like that's what they're telling you. What's that?
You'll be like,
Yeah. So it's going to be two triangles possible.
they're like, you know Mr. Rushka? You don't do that.
All right. So yep. So and then we filled in everything, right? Okay. Cool. So do law of cosines. Law of sines. Sine A over A equals sine big B over little b equals sine big C over little c. Okay. Whoa. Whoa. Let's plug stuff in. Okay. So little c is 10. Big C is 32 degrees. Okay. Little a, and they gave us little a and little b, right? Yeah.
Just a little bit.
Just little a, okay. Yeah. Thank you. Okay, so let's start out right here. Yeah.
The bottoms on both of them are 10, but like.
Did I mess something up?
No,
You just have to
it's
change little a to 18.
Oh, sorry. Thank you. Sorry about that.
If they were both 10, they'd be equilateral.
That'd be a whole other situation going on. They could be isosceles, at least. Maybe equilateral.
But
Okay.
the tops would match.
Yeah. With the tops match. Yeah, they'd have to, right? Yeah. Okay. So let's think about this, right? What are we going to cross multiply? We could do A, right?
C with A.
Yeah. So let's cross multiply these two, okay? So we know that sine 32 degrees all over 10 equals sine A all over 18. Okay. Okay, so we get 18 sine 32 degrees all over 10, so I multiply both sides by 18. Okay. And how do we get A by itself? Inverse sine. Good. A is going to be that. still on radian mode. I was like, what? There we go. 72 point. I got 72.5 degrees. So you guys got 72.5 degrees. And then how do I get that third angle? What's that? Yeah. We're going to give us 75.5 degrees. Okay. Big B. All right, so let's do that real quick.
What are we solving for right now?
Little b, right?
Yeah.
Yeah, so let's cross multiply these two right here. So we'll get b sine 32 degrees equals 10 sine 75.5 degrees. Use the bathroom, yeah, you good. Okay. Divide both sides by sine of 32 degrees. So we get b equals about 18.3. Okay, so that's going to be one possible triangle right here. So B was about 18.3. All right, it's going to be one possible triangle. Did you guys follow that? Okay. All right, I'm going to go ahead and move on from this because I'm not sure what's going on. Can we go ahead and do the word problems? I'll make a video notes. What's that?
There are two possible triangles.
Yeah, there are. Yeah.
How do you know?
Looking at the notes. Looking at the notes, Kate.
Oh.
Yeah. So yeah, I'm going to muff this if I try to do it right now. What's that?
There's no way for us to know after something. Like,
No, I'm going to show you. I'll make a little video notes on it. If that's okay. Yeah, so I was going to look over this in alpha, but a bunch of people came in for help, so I didn't get the chance to. All right, let's just move on to these word problems, okay? Are you guys feeling okay about solving these triangles, though, for now?
Yeah.
All right, sounds good. And you see what happens when there's a zero triangle case? Yeah, okay, sounds good. All right, let's move on to the word problems, okay? So observers, so you got two people, they're 2.32 miles apart. They both see the same hot air balloon, okay, right here. All right, and they want to know the distance from the balloon to the ground. So they want to know that. It's going to be our x, okay? Find the altitude. It's height from the ground straight below it, okay? So how might we do this, you think? How do we get x?
We already know one of the angles would be 90 degrees.
Yeah, so this is 90 right here.
We just solve that like a glass one.
Yeah, so what do you think? What do you want to find?
Don't you find the bottom by just finding that 2.32 by 2?
We can't divide it by 2. This is not split into halves. That's not split into halves. So there is something we can fill in. What can we fill in here?
The third angle.
You can fill in the third angle. What's that third angle going to be? How do we get that third angle?
So
That's easy, right?
90
Yeah, just 180.
plus 62.
Yeah, so we can do that. We can do this is going to be 28 minus 90 minus 28. So that'll be 62 degrees right here. Sorry. Okay. Other side, it's going to be 90 minus 37. It's going to be 53 degrees. Okay. The whole thing combined is going to be 62 plus 53. So the whole angle is going to be 115 degrees, okay? What I can do is, if I know this side, I'll call it little b. If I know little b here, I can just do sine of 28 degrees equals x over b, right? Do you see that? If I knew what b was, if I knew this length right here, I have a right triangle, I'm trying to find x. I'm trying to do sine 28 degrees equals the opposite side over the hypotenuse, right? So that would be, right, so sine 28 degrees, this is like what we've been doing, equals x over b, right? Or b sine 28 degrees equals x, where b is this distance right here, okay? Do you guys see how that will give me x? Like how this relation holds sine 28? Okay. So I just need to find b, right? If I can plug something in for b, I can just plug it in my calculator and I'll get that height, right? The height x, okay? Are we good so far? So how can I find that b right there? I can use what? Law of sines, okay? So I'm going to have sine 115 degrees over 2.32. So Kate Phillips, you're on the right track. We just have to use the whole bottom side. And that's going to equal what? How do we find little b? It's going to be, what's the angle that's across from little b?
37.
It's going to be sine of 37 degrees divided by little b. Okay? So it's cross multiply. Divide both sides by the sine of 115 degrees. Okay, so I'm going to plug that. Are you guys comfortable plugging this into your calculator, or do you want me to show it again? Okay. Just So make sure you're on degree mode. So I got that for my B, okay? And I just need to plug it into, I just need to multiply it by sine 28 degrees, okay? So just take that B, multiply it by sine 28, that'll give you your altitude. 0.72 miles.
Wait, you said divide by what? 28?
Multiply that B by sine of 28. Right? Because B sine 28 equals x, right? And little b we can get in our calculator by doing that. So do that, and then once the screen says 1.540, just multiply it by sine of 28. That make any sense? You guys following? Okay. Is that all right? Okay. Can I move on to the next one, or any questions on this? Okay. So you guys followed, all right? Right here, okay, so there's two meteorologists. They're sitting on a road. There's a tornado in the field next to them, okay? There's 38-degree angle right here, 53-degree angle right here. They want to know, find the distance between the tornado and the road. So we want to find H right there. We want to find H. Okay, so there's a tornado, here's the road. Distance between the tornado and the road is right here. Okay.
So where's the 38, 53 inside the triangle or
38 is right here,
outside of it?
outside. So how would I get the angle that's right here?
90
90 minus 38, yep. That gives you 52 degrees. And then 90 minus 53, that'll give you 37 degrees right here. Okay. And then we can just ignore, after that we can just ignore these two. That's just going to confuse you guys. Okay. So we want to find H, right? We want to find H. Okay. Yep, so sine of 52 degrees, good job, Ben. Sine of 52 degrees is going to equal H over little b, right? Okay. Solving for H, right, we're going to have b, little b times sine of 52 degrees equals H, okay? How can we find little b? Yep, law of sines, right? So we need this angle right here. What's that going to be? 180 minus 57, or 37, sorry, minus 52. It's going to be 91 degrees. Okay. So sine of 91 degrees all over 25 equals sine of 37 degrees all over little b, okay? Where did I get the 37 from? Why did I pick 37 and not 52 degrees? Why did I pick this angle and not that one? I want to find little b, right? So I got to do the angle across from it. Yeah. That make any sense? So let's multiply both sides by b. Okay, to get b by itself, I'm going to multiply by 25 over sine 91 on both sides. right? When we multiply two reciprocals together, they cancel. So I have b equals 25 sine 37 degrees all over sine 91 degrees. Okay. So let's do that in our calculator. Okay, so I have 25 sine 37 over sine 91, enter. And then when I wrote down my equation that involves x, I have to multiply that answer by what? Sine of 52. Now I multiply by sine of 52. So 11.9 is my answer. So the tornado is 11.9 miles away from the road. Okay. And then it also says here to find the distance from each meteorologist to the tornado. We actually got that, right? This meteorologist is B away from the tornado. You guys see that? So little b is that answer. So what do we get in our calculator? I got 15.4 miles, 0.4. And then how would you guys find little a here?
Just solve them all.
We can skip this, but how would you find little a here? You just use law of sines, right?
Yeah.
Yeah. So you'd have, I just use sine 91 over 25 again. We do sine 91 over 25 equals, it would be sine 52 degrees. Now we do sine 52 degrees. All over little a. We do that. Okay. Any questions on that?
We didn't, like, if this was on a test, we wouldn't have to do all that. We would just have to find H, right?
I don't know. I haven't seen the test. I have a quiz. It's not hard though.
But it's not, was it?
You want to be able to find all three. You can find them, we'll try.
Yeah, but were they looking for those, right?
Yeah, they were actually. You'll get 3 points though, right? If you know how to use the law of sines to find H, you can find B and A. Right? Finding H is probably harder. Any questions, comments, concerns? I think that's a good stopping point. I'm not just going to try to rush the last one. Okay, sorry about that. So I'll put out a video for you guys to watch over the weekend doing 5-6. That's law of cosines. And then we'll talk about, I'll do this last example in 5-5, and then I'll talk about the ambiguous case with 2 triangles. Yeah. There's going to be 2 triangles. So if you go to the beginning of the problem, there's going to be 2 triangles. There's like 2 different combinations of that. Yeah. I'm not sure why. That's why I need to go study this.
That's fine.
Sorry about that.